Good morning, chemistry. Hope everybody's doing well and staying safe. Um, I want to talk a little bit about the behavior of solutions. We were talking about 12.2. I know you guys have already done the questions and turned them in, I hope. And I just wanted to go over a few things. So, solution equilibrium is where you have the undissolved solute remains constant. So, the amount of it is constant. There's two processes going on when you have a solution. You have the solute trying to dissolve, and that's dissolution. And then when the solute is trying to come out of solution and form crystals, and that's crystallization. So those two things are happening all the time. And if you have it balanced, or if it is balanced, then your solution is going to stay stable. Okay, so solubility, one more time on this. You have unsaturated solution, which means that you can dissolve more solute. Saturated means you cannot dissolve any more solute. And supersaturated is when it becomes unstable and crystals form like we did in the lab. All right, so supersaturated solutions can be achieved by increasing the temperature. Remember when we did the supersaturated solutions to make the crystals, we had to increase the temperature so we could get more of the solute in the solution. If we had allowed it to cool and didn't disturb it, it would have remained in solution. But if you have a rough surface, like we put the pipe cleaners in there, that's a rough surface, and that allows the solute to attach to something and to grow, to congregate, if you will. So that's where you do. It's called crystal seeding. You don't necessarily have to put a crystal in. What we did, remember, we put the pipe cleaners in, so that still gave the solute somewhere to go, somewhere to attach to, and that's why our crystals grew. Okay, pressure also affects solutions. It will not affect solutions if they are liquid or solid solutes, or if you're putting gas into another gas, but it does affect gas trying to be dissolved into a liquid. So like soda and air freshener and anything that you have in a spray can that's under pressure, that's what you have a gas dissolved into a liquid. And there's something called Henry's Law, and that just means the higher the pressure, the greater the solubility. Okay, so we're talking about soda or cola. It releases gas when you open it. So that's that fizz when you open a can or a bottle. If you are shaking it or dropping it, which I'm sure you've seen this happen or done this, then you're going to get just a geyser. It's going to release too fast. If you stir or you leave the pressure that is released, it's going to go flat. So that just means when you leave a cup of soda out and you don't put it, you don't have it in the bottle anymore, it's just in a cup, that all the pressure is released and it goes flat. All right, and that leads us to decompression sickness. If you know divers or you've seen this on TV or a movie, divers have to go back to the surface slowly. So they have to descend slowly and go up and rise to the surface slowly because they have nitrogen gas bubbles in their bloodstream. And you have to get that to gradually escape from solution. If the nitrogen is released too quickly out of solution, it's going to form bubbles, and that can obstruct blood flow, and that causes the divers to go through symptoms similar to a stroke. And it is very dangerous, and they could actually die. That happens a lot when divers are not trained. So that's just another example of the a gas being released from a liquid. All right, temperature can make solids more soluble in a liquid, and that's what we saw in the lab, where we raised the temperature and we could get more of the solid into the liquid. And raising the temperature can make gas solids less soluble. So if you remember when we were looking at the chart, the solubility graph, that solids will go up. So the solubility increases with the increase in temperature, but the gases will actually, the solubility decreases with the increase in temperature. So you're going to see the gas lines on the graph are the ones that are broken lines, not the little dashes. Those are the ones that are going to go down, and that just means that a gas has less solubility the higher the temperature. That's why you want to have cold soda or cola. You want to make sure that you keep your drinks cold so they're more fizzy. You don't want to drink a warm drink. I'm sure you may have seen this happen where you had cans of soda and then you didn't put them in the cooler. Well, they're not as good because they're warm, and they're not as fizzy because the gas is not as soluble. So that's the reason that you want cold soda. All right, the solution process has 3 parts to it. The solid separates from the crystals, so that just means when you're putting in a solid, it's breaking up. So the particles are separating, and that's an endothermic process. The solvent particles move apart and make room for the solute particles, so everything kind of makes room for each other, and that's also endothermic. Then the solute and the solvent particles interact with each other. They may attract each other, and that depends on the attraction between, if you have a molecule. I know the video talked about this. If you have a molecule that it has more than one element in it, sometimes those are more attracted to each other than they are the solvent, like the water. And that's why some things are not soluble. The things that are soluble will move apart and they're more attracted to the water. Okay, enthalpy of solution. This one's kind of something you may not have heard. Enthalpy of solution is just the total heat absorbed or released when a solution is created. So on the last step of the solution process, you've got some type of energy release or energy absorption. On the net energy can be negative or positive, so that's why it is a release or an absorption. A positive number means the heat is absorbed, and the negative means the heat is released. And I have that backwards. The negative means heat is absorbed, and the positive means the heat is released. And it depends on the amount of solvent present. All right, so some examples. The little hot packs and cold packs that you have. I know you guys have seen them where you break them and then the chemicals mix, and that is the chemical reaction that's caused by that will either release heat or it will absorb heat. So that's why some of them are hot and some of them are cold. Okay, make sure you've done your 12.2 section review, and make sure that you upload it to Homework Drop. I think it's already due, so go ahead and get that done so that we can move on. Talk to you later. Take care. Bye.